Good evening, guys. Can you all hear my voice loud and clear? Is the screen visible to all of you? Can you guys confirm?
For me, it's clear.
Okay, Akshay, Sudhir, Amar, all right. Cool. So let's get started, guys, with the day 4. So today we would be looking at the classification techniques for supervised machine learning. Okay. So as a part of that, we will start off with first what is classification. Okay. What are classification kind of problems? So yesterday we looked at the regression kind of problems. So typically by and large, we usually solve regression and classification types of problems using machine learning. Okay, out of which we have already looked at simple linear regression and multiple linear regression yesterday. Okay, we saw how we can use ordinary least squares to fit a line. Okay, and develop a prediction model, basically a regression model, right? A regression equation. All right. So I hope session was clear yesterday and the recording is also available for you to revisit it. So today what we are going to do is we're going to look at what is classification first, okay? And then we'll look at one of the classification algorithms that is widely being used, okay? All right. Okay, so let us look at the formal definition of classification. So any idea what is classification, guys, as per your understanding? What is your perspective of a classification problem? How do we define a classification operation? Anyone? Segregation, Sudhir. Okay. All right. Systematic arrangement. Okay, Chandrika. All right. Any other views? So Rohit, it's always not a cat or a dog. Okay, so probably Rohit is talking about image classification. All right. I'm talking in general, what is classification, Rohit? Need not be a image classification. Okay. All right. What else? Action of classifying. Okay. All right, Sirisha. All right, let's look at the formal definition of what is classification. Okay. So tell me, what do you understand out of this definition? So the definition says partitioning the feature space into pure regions assigned to each class. What do we understand from this definition, guys? According to specific criteria, classification is done. All right, Maithili, almost there. So I put up the formal definition of what is classification, guys. Tell me, what do we understand from this particular definition? Or is it difficult to understand? We need a simplified version of the definition. What do you think? Or have you guys understood what the definition says? Anyone? Or do we think there are too many jargons into the definition that we need to break down and understand so that we can understand this formal definition of classification? What do you think? Splitting the things into their respective classes. Okay. Okay. So you are telling me the process, Chandrika. Technically, what is classification? That separates the data into different techniques, is it? Segregation depending on properties, all right. But what do we understand from this definition? Is the definition clear to you guys? Can you guys see the slide? Can someone look at the definition and tell me, did it make sense to you, or do we need a simplified version of the definition? If you guys have already understood, just say yes, then we shall proceed. We can skip the discussion on classification and we can directly jump onto the algorithm. But if you think that you're not clear with what is classification and the definition is too complex, we need to simplify, we can break it down. So do you want me to break it down? Okay, Sankirtan is saying not clear. Okay, so do we need to break it down, guys? Simplify. Okay. All right, let's take an example and try to simplify the definition, guys, and then we'll revisit this definition. Okay. So let us take one example. Okay, I'll just show you one data set. Okay, and we'll use it to understand what is classification. So let us say we have a data set like this. Let us say we have age. Okay. And let us say we have collected this data set about salaried people. Okay. So salary. Okay. And based on the age and salary. Okay. So let us say these are your variables or your features. Okay. In machine learning language, they are called as features. So let us call them as feature 1 and feature 2. Yeah. Can I call them as features? Yes, guys. Do we understand what is a feature? These variables are nothing but also called as features. Okay. Now, based on these features, okay, we want to make a decision. We want to make a decision whether or not we should give the loan to the person or not. Okay. So let us say loan approved. Okay. So this is your target variable or your Y variable. Remember, guys, we are discussing about supervised machine learning. So there has to be a target variable. So based on these features, you are going to take a decision whether the loan will be approved, yes, or whether it will be rejected. Okay. So let us say, let us take examples of age is 23. Salary, let us say it is 15K. Okay. And let us say loan was not approved to this guy. Okay. Let us take age is 25. Let us say salary is 20K. Okay. Let us say loan was not also approved to this particular guy. Okay. Let us say there's another person with 28 years of experience. Let us say the salary is 40K. Okay. And let us say he was approved the loan. Yes. We have another person with age 30. Let us say salary is 45K. Okay. Just for understanding purpose. Let us say he also was granted a loan. Age is 32 years, salary is let's say 50K. Okay. And the bank has granted him also the loan. Okay. Data set clear, everyone? Are we following this data set? Pretty much simple. Yes. Okay. Now, what I'm going to do is, can I plot this data if I want to understand, whether there is certain relationship between age and salary? How do I determine whether there is certain relationship between two variables? What do we need to plot for that? Scatter plot, simple, right? So let us do one thing. Let us plot a scatter plot. So x-axis, y-axis, okay. So let us put age on x-axis. Let us put salary on y-axis, right? So this is what, guys, this is your feature 1 and this is your feature 2. Okay. Since I'm plotting a scatter plot of the features, okay, this entire thing, okay, is called as your feature space. This entire thing, okay, let me take a different color and just show it to you so that you guys can make some sense out of it. So let us take a very faint color. Okay, so this entire space, okay, this entire space is your feature space, guys. So this entire space with the green dots, right, that I'm showing you. So this is your feature space. Okay. Now let us take the data points. Let us take the data points and try to plot the data that we have in our data set. Okay. So what I'm going to do is I'm going to take, let us take the blue color. Okay. So for age 23 and salary is 15K. So let us start with 10K salary. Then we have 15K salary. Let us say then we have 20K salary. Okay. So let us say then we have, this is 25K. Let us say this is your 30K, 35K, 40. Okay. 40K, 45K, and let us say this is 50K. Okay. So let us go and start plotting it. Let us start the age from the scale of, let's say, 15. Let us say this is 20. Let us say this is 25. Let us say this is somewhere 30. Let us say this is 35 over here. Okay. All right. Now what we are going to do is we are going to plot these data points. So first data point is age is 23 and salary is what? 15K. So age is 23 somewhere over here. Salary is 15K. So this data point will be somewhere over here, which is over here. Okay. Second data point, age is 25. Salary is 20K. Somewhere over here. Okay. Then let's go with the third, 28 age and 40K salary. So 28 age is somewhere over here, 40K is somewhere over here. Okay, so let me do one thing. Let me take another color. So let us say 40 and 28, right? Somewhere over here. So I'm going to draw plus over here. Then we have 30 and 45. 30 and 45 somewhere over here. Okay. 32 and 50K. So somewhere over here. Okay. Now tell me guys, what are the respective labels? Labels in the sense, what is the loan status for all these data points that we have plotted? Okay. So let us talk about the first data point. So the first data point, second, third, fourth, and fifth. So first and second data point, as you can see, they have not been granted a loan. So I'm going to just put them as label no, label no. Okay. Can I put it like that, guys? I can, right? And let us take this plus signs wherein we have yes, yes, and yes. Okay. Now, can I draw a line which separates these two classes? Can I draw a line like this and separate these two classes, guys? Yes. Now, do we have all the no people who are not granted a loan, the N label, right? No class. So basically, do we have the no classes on one side of this line and all the yes class data points on the either side of the line? Yes or no? Yes. This line which separates these two classes, yes and no, is called as your decision boundary. What is it called as? It is called as decision boundary. Why it is called as decision boundary? Because this boundary is deciding whether a new data point, let us say tomorrow there is a new data point coming into play. Okay, there is a new person who is applying for a loan. Let us say he is applying for a loan. Okay, so this is a new data point. Okay, let us say this is a new data point. Now tell me which side of the boundary, decision boundary, is the new data point lying, guys? Can anyone tell me? It is falling on the N, right? These are all no classes, correct? So this is falling on the N or the no side of the classes, and any point which is below this line will be assigned a no class. Basically, if there is a person tomorrow with age, let's say 26, okay, and salary somewhere around, let's say, sorry, age somewhere around 25K and salary around 26K, okay, we are going to not grant him a loan. So tomorrow, if there is a person coming with, let's say 20, 5 years of age and salary around 26K. Okay. We are not going to grant him a loan. How did we arrive at this particular decision? Based on this particular plot, okay, we have decided that since this point is falling below this boundary, decision boundary, we are going to assign a no class to it. So if you look at this, okay, all the data points falling below this particular decision boundary are belonging to the no class, or they were not granted loan. And all the data points towards the other side of the decision boundary have been granted a loan, okay. And this is also called as a yes class or a positive class. Now, if you see here, since there is no such data point with an n label in this particular space, right? There is no such data point with an n label, right? They're all y labels. This is called as a pure region, okay, belonging to the y class. Okay, and this is a pure region, belonging to the no class. Okay, now let us go ahead and revisit our definition. Okay, partitioning the feature space. What is classification? It is an act of partitioning the feature space. Okay, now what is the feature space? So this is your feature space, guys. You have age as one feature, salary as the other feature. Okay, and this particular space that we are looking at, okay, this is called as your feature space. Now we are trying to partition the feature space using a decision boundary, right? So what is the definition saying now? Partitioning the feature space into pure regions which are assigned to each of the classes. Now, what are the classes we had? We had the yes class and we had a no class, right? So what we have done, we have partitioned the feature space using a decision boundary into pure regions. What is the meaning of pure region? If all the data points falling to the either side of the decision boundary belong to the same class, be it yes or no, right? Now, in this case, they are all yes class data points. So if all the data points belong to the same class or have the same label, okay, of the target variable y, okay, then we are going to say that this is a pure region. Okay, and if say by mistake there was a yes data point here in this as well, then this will not become a pure region. Why? Because 3 data points are belonging to the n class, but there is 1 data point which is belonging to the y class. In this case, this will not be a pure region. Only this particular region will be a pure region. Is the concept clear, guys? Are we clear with the terminologies? What is a feature space? Okay, what is the decision boundary, and what is the meaning of pure region? These concepts are very much clear in order to understand what is classification. Are you guys with me so far? Any questions or queries before we move ahead? Crystal clear? Now, is the definition making sense to all of you guys? It makes sense now, right? Partitioning the feature space into pure regions assigned to each class. That is the act of classification. Okay. All right. Now that you understand this, now tell me, okay, in this particular plot or feature space, okay, are we looking at a linear boundary or are we looking at a non-linear boundary? First and foremost thing, यहाँ पे decision boundary है क्या? Is this plot containing any decision boundary? Yes, this is your decision boundary, guys. This is your decision boundary, right? And in this case, it is a non-linear decision boundary, right? And it is trying to separate the data points, okay? So let's say all these data points belong to red class and all these data points belong to the blue class. So here we are trying to separate, okay, the data points into 2 different regions, okay? So this region belongs to the red class data points. This region belongs to the blue class data points. Now tell me, are both these regions pure regions, guys? दोनों region pure regions है क्या? When will I call a certain region as pure region? Okay. So Sudhir is saying no, they are not pure regions. Why, Sudhir? Why they are not pure regions? Because of these data points, right? There is a blue data point in the red region. Okay, you can see over here as well. You can see here as well, right? And also similarly, in case of the blue region, we have this red data points as well. So in this case, we don't have a pure region, completely pure region, but they are called as sufficiently homogeneous. Now, what is homogeneous? Homogeneous in the sense belonging to the same category. All these data points belong to the blue category, right? All these data points here belong to the red category. So we are going to say that this is sufficiently homogeneous, or it is sufficiently pure region. Okay. It is not completely pure region, but it is sufficiently in the sense majority of the data points are belonging to the same class. Okay. And we can say that this is a sufficiently homogeneous region. Okay. So this is a feature space with feature 1 and feature 2. Okay. So this is a decision boundary that we were talking about, nonlinear decision boundary. This is a region 1 belonging to the red points, region 2 belongs to the blue data points. Okay. And since because of these some misclassified data points, there is certain classification error which is 0.015. Okay. But so far, is the concept of classification clear to all of you guys? Do we now understand what is the act of classification? Very much clear? All right, great. So tell me guys, what kind of a line can I draw in order to separate the red and green data points? If I want to draw a simple decision boundary, how should I draw the line? Should I draw the line like this? Should I draw the line like this? Or what do you think? Should I draw the line like this? How should I draw the decision boundary? Okay, you guys are saying non-linear, but I want to go for a simple decision boundary. So when I say simple decision boundary, I will not go for a complex or non-linear one. Instead, I will go with a simple line which separates both of the data points. So the orientation of the decision boundary or the line should be such that I should be able to cover maximum number of data points of the same class on one side. Okay. Basically, there should be minimal classification error or minimal non-homogeneous data points falling in the same region. So how can we achieve that? So if I draw a line like this, I'll be able to achieve sufficiently homogeneous regions. Do you guys agree with me? Can I draw a simple decision boundary like this to separate the two classes? Yes. Now this, when I draw a simple decision boundary, such as a linear boundary, there will be still some classification error because there will be some data points which will be still be misclassified, right? On this side as well, on that side as well, right? So we are not ending up into a pure region. Let us take another example. Let us take a medium decision boundary. Now, when I say a medium decision boundary, okay, I have made the decision boundary somewhat non-linear. So I have achieved, okay, better classification as compared to the simple boundary, correct? Are the data points here less number of misclassified data points? Have I got maximum purity over here by using a nonlinear boundary? Yes, right? But have I achieved completely pure regions even though I'm using a nonlinear boundary? Are these two regions pure regions? This red region R1 and this green region R2. Are they pure? Pure? No, it is not completely pure, right? We still have this data points which are still misclassified. So what if I want to achieve 100% purity, guys? What should I do? I have to go for a complex decision boundary, right? Let us say how a complex decision boundary might look like. Oh, these are like all different structures, right? Amoeba and all, single nucleus. Slowly we are getting into a biological class, right? All different shapes and sizes. So we have to individually draw boundaries around each data point in order to achieve this 100% accuracy, guys, 100% purity. But do we need to beat our head so much to achieve 100% accuracy? Probably not, right? If we can live with a little bit of minimal error, right? So that should be fine. Okay. We need not stress too much in order to get the 100% accuracy. Okay. I'll tell you why I'm talking about this thing. Okay. We'll just come to the concept of, how much complex you should make a decision boundary. The decision boundary is nothing but, the model that you're trying to build in order to classify the data points belonging to each region. Okay. So how much complex you should make the model? Okay. Whether you should make too complex, you should make it medium complex. Okay. Just like your medium decision boundary, or you should make a simple model, which is just like a simple linear boundary, right? So which kind of a model we should go for? Okay. So let's try to understand that. Let us say if these are the data points, okay, that are existing. We recently, yesterday only we studied about the linear regression, right? So if I have to draw a line representing these all data points, how should the line be, guys? How should the line be? We'll talk about what is noise, Rohit, don't worry. But first tell me, if I want to draw a line which is representative of these data points, how should the line be? Yes, it should be a straight line, is always straight. That's correct, Rohit. But yesterday, what we did discuss? We discussed that the line should cover maximum number of data points, right? Yes or no? We did study linear regression, right, yesterday? So let us see, if I draw a simple line which is trying to represent these data points, right? So what will happen? Here, there will be errors which are introduced, okay? So if you see here, this is the error. So I will just change the color. So this is the error. This is the error, right? This is the error. This is the error. Error. Remember yesterday, I asked you which of the two lines is the best fit. Do you guys remember or did you forget? Remember, yesterday we talked about this. So this is nothing but the error, right? We want to build a line which will result in minimal error, correct? So if you build this kind of a line, right, we can see that there will be errors, okay? So there will be prediction errors, okay? So this model is too simple. If you just use a simple decision boundary or a simple line, this is a simple model, okay? Now, if I draw a line which is covering each and every data point, in this case, I'm drawing a non-linear line, okay? So if I use a non-linear line, I'm able to cover each and every data point, okay? But the model becomes too complex in that case, okay? So what kind of a model are we aiming at? We don't want a too simple model. We don't want a too complex model. Then what is the model that we are trying to build or we want to build, okay? We should build something called as a generalized model, okay? The model which is just right, okay? When do we say it is just right? So basically it should be trying to cover as much points as possible, but it should not stress too much to cover each and every point, okay? So that is called as a generalized model. So if I have to give you an analogy to understand this particular concept, okay? So let us talk about three students, okay? So this is student one. So we have, this is student two, okay? Let us say we have a student three, okay? Now student one, what does it do? Student one just wants to pass the examination. So his goal is to just achieve 35% of marks into the exam. Why? Because he just wants to pass the examination. So do you think he will study day and night in order to get 35%? So if I have 10 chapters in a subject, will he study all the 10 chapters? No, right? He would hardly study 3 or 4 chapters. Okay, no engineer will study, right? Prior to the exam. Yes, that's very much true. So basically, if his goal is to just attain 35%, right? He will not stress too much. What he will do? He will just do 3 to 4 chapters so that he will just get 35% and he will just pass the exam, right? So this kind of a person is a person who is under learning. When we say under learning, he is not learning the subject completely. His goal is just to pass the exam with 35% marks. So he's going to underlearn, right? He's just not going to take too many efforts, right? He's going to do simple study. He's not going to do too much of study. He's going to simply look at few chapters and attain the objective of 35% of passing. Let us say there is another person too, whose aim is to achieve 99.9% in the exam. Now tell me guys, how will this person study? How will this student study for the exam? So if we have 10 chapters, will you only go through 3 or 4 chapters, or will he by heart all the 10 chapters of the subject? So Rohit is saying, yeah, he will study 24 across 7. Yes. Chandrika is saying a lot of efforts. Yes, he's going to put a lot of efforts, right? Because he wants to obtain 99.9%, right? He will study day and night. So will he study all the chapters? So this guy will study out of 10 chapters, he will, let us say, study 3 chapters. What about this guy who wants to attain 99.9%? Will he leave any chapter from the subject? Or will he study all the 10 chapters? We'll study all the 10 chapters, right? Because he does not want to lose even a single mark, correct? So we'll study all the chapters. So this is a representation of a complex model. A complex model, okay, in order to achieve maximum accuracy, in order to attain maximum accuracy, it will try to cover each and every data point, which means that like this student who wants to attain 99.9% percentage in the exam, he will mug up all the 10 chapters. Obviously, right? If a person has to understand each and every chapter, it will take much time for him, right? And engineering people know they don't have that much time to study, right? You have limited time to study and maximum marks to obtain, right? So that the goal is like an optimization problem, right? Minimal time and maximum marks to be obtained. So what they will do, instead of 10 chapters, they will usually go for 7 to 8 chapters, okay? And they will prepare it thoroughly such that even if you twist the questions, if you tweak the questions, they will still be able to answer those because they have understood the concept. So the goal here is of this particular person, okay? So this person's goal is to achieve 80 to 85% marks, let us say, okay? So this person is your general student. The general student, okay, wants to obtain maximum number of marks, okay, but he is not like this particular guy who wants to obtain 99.9%, okay. This guy is our generalized student or generalized model whose aim is to achieve maximum performance, but at the same time, he wants to understand the concepts. He is not going to just mug up the entire textbook in order to obtain the 99%. He will understand the concepts. He will do 7 to 8 chapters only, but he will study them thoroughly so that even if you ask the questions, if you tweak the questions left and right, in whichever way you ask the questions, they will still be able to answer the questions and obtain at least 80 to 85% of the marks, right? So this is our generalized student, and we also want to build a machine learning model, okay, which does not give me 100% accuracy. Why? Because a model with 100% accuracy is just a myth, okay? Just like a person who tries to obtain 99.9% of marks in the exam by understanding, there is no time for that, right? The person has to study right from childhood then if he wants to obtain 99.9% marks, right? Basically, unless you memorize, you completely rectify that concept, the entire textbook, right? It is impossible to obtain 99.9%. So in applying the same logic in machine learning also, you can never obtain a model with 100% accuracy. You have to build a model which will generalize on the data in the sense, okay, whatever data you train with. So if I have to talk about train and test, the two concepts in machine learning, okay? So train and test. So think of this as training phase of the model as your unit test exam, okay? So if I conduct a unit test for you guys, I give you a subject, okay? Let us say we are talking about physics. Just I'm taking a general example, okay? So let us say we are studying physics as a subject, okay? So what I do, I'm going to take your unit test, okay? I'll tell you that in the unit test, I'm going to ask you 10 questions. Okay. So what I'll do, I'll give you the 10 questions and also their 10 answers. And I'll ask you to go through all the questions and answers, understand them, and come prepared for the unit test. So what you will do, you know the question, you know for which question, what is the answer. So you understand for which question, which answer is there. Okay. And when I take the exam, okay, when I take the unit test, okay, I'll ask out of these 10 questions, I'll ask 5 questions. Obviously, we'll do good, right? Because you know all the questions and what are the respective answers for those. Correct? So that is nothing but your training phase in your machine learning model. I train the data, okay. I train the model with the data such that I will give him all the details like your X variables, input variables, as well as your target variable, which is your Y variable. I'll give both of them. I'll give them the questions and the answers both, like this particular exam, right? I'll give you questions and answers both. So in this case of the training phase of the model, I'm going to give it both your input parameters as well as output parameters, and the model will try to establish a relationship between your input and output, and it will try to learn that relationship. Okay. And if I pick the same record from this particular input data, it will be able to correctly predict by, because it knows the question and answer already. Okay. So in training phase, your accuracy of the model will always be high. It is always high because it knows both the questions and answers. But what we will do in test phase, okay, just like over here in the unit test, you will pass with good numbers because you know both the questions and answer. But in the final exam, what I will do, I will tweak the questions. I will tweak the questions in the sense what, I will not ask the questions in the same format. I will change the format. Though the answers will remain the same, I will tweak the questions such that if the student has really understood the concept, he should be able to answer, or else he will not be able to answer. He will fail miserably. Okay. So people who mug up or ratify, right, for this question, this is the answer, they will fail. They will fail in the final exam. Okay. Because they just learned that for this question, this is the answer. They did not understand the concept. They did not understand the logic. Okay. And that is the reason if I change the format of the question, they will not be able to answer. Okay. So for that, a machine learning model which has really understood the underlying pattern, it will do good in the test phase. In test phase, we don't give the Y labels. We just give the X. Okay. And we'll ask it to predict the Y labels. Okay. We'll ask it to predict. And we will say that, okay, if the prediction is closer to the actual values, then we say that our machine learning model is doing the good job and it can perform better on unseen data, the data which it has already not seen in its life, right? So if it has correctly captured the pattern, it will be able to do the predictions with a good accuracy. Okay. So we'll always work with two different kinds of accuracies in machine learning. One is your train accuracy and one is your test accuracy. So whatever is the test accuracy, that is your final accuracy, okay, with which you will finalize whether your model is good or it is going to require more training. Okay, guys, are we clear so far? Are you guys with me? Is the concept easy to understand? Do we understand what kind of a model we should build? So what kind of a model we should build? Underlearn, memorize, or generalized? What kind of a student do you want to become? The one who wants to pass with 35% of marks, the one which 99.9, or we just need a general person? Yes, you guys are right. We need to build a generalized model. Okay. We should aim for maximum, but we should not just mug up, rectify, memorize the answers to the question, but we should also understand the concept, right? So similarly, we want to build a model which understands the underlying patterns in the data. Okay. All right. Very good. Let's move on. So the goal here is to generalize and not memorize. Okay. So remember, guys, people working into the machine learning field will always have to remember this graph for lifetime. Okay. So what are we plotting here? We are plotting here model accuracy as opposed to the model complexity. So on the x-axis, we are plotting the model complexity. So let me write over here. Okay. And on the y-axis, we are going to plot the model accuracy. Okay. Now, as you can see over here, this is your training set accuracy. As I said, always training set accuracy will always be high. So if you see here, even if you make the model more and more complex, the accuracy will keep on increasing and higher. Okay. Why? Because here training set accuracy is nothing but giving you 10 questions and giving you 10 answers. And then asking you from this 10 questions only, if I ask you 5 questions, you'll be able to give me the correct answers for all those 5 questions, right? Hence your accuracy will be high. Your marks, the score that you will obtain will be always be high in a training set accuracy. And that is the reason you can see the graph is always increasing. Okay. But your real crux, your real talent is tested in the final exam. Okay. So as it is tested in the final exam, right? Here your test, it is also called as validation. Okay. So test as well as validation are one and the same. Okay. So test accuracy or validation set accuracy is nothing but the unseen data. How does your model perform on unseen data? Okay. If your model is able to perform good on unseen data, it means that it has captured the underlying pattern. Okay. Now, in order to build a good model, you need to have good features. For example, okay, let us talk about this model complexity parameter. So yesterday we looked at, okay, the regression equation such as y cap equal to beta naught plus beta 1 into x. So here there is only one variable x which is helping us predict our target variable, which is your y variable. Okay, but let us say here r square is almost close to 0.60. Okay, is it a good model, guys? If this particular simple linear regression is fetching me 60% accuracy, is that a good model? Just an average, above average, right? Not so very good model, right? So what do? We say that x alone is not able to explain the complete variation in y, which means that there are some more variables involved. Okay. So what I will do, I will rephrase the equation such as y cap equal to beta naught plus beta 1 x1 plus beta 2 x2. Let us say I'm adding one more variable. Okay. And this r square goes to 0.65. So the accuracy improved by 5% because of addition of this new variable, which is also contributing in determining the value of my target variable. But let us say if I add one more, beta 3x3, okay, and this r square goes to, let us say, 0.70. So what is happening, guys? As I'm adding more and more features to the equation, is the accuracy going up? Yes. So the more and more number of features you keep adding to the algorithm, or if you keep adding to the model, your model starts getting more and more complex. So that is what you mean by model complexity. Okay. So if I just have one variable, my accuracy will be very low. Let us say I add one more variable. Okay. This is x1, x2. Let us say I add one more variable, x3. If I add one more variable, x4, what is happening? The accuracy keeps on increasing. Okay. But if I dump all the features, okay, let us say if I have 100 features, okay, so this is up to x100. If I have 100 features and if I dump all the 100 features into my equation, what will happen? So Rohit, it will not increase in infinity, right? We have a percentage. Percentage can be 0 to 100, right? Can I have a percentage up to infinity? No, right? So basically, your model will give you 100% accuracy. But as I said, right, a model with 100% accuracy is a myth. Okay. If someone says my model is performing at 100% accuracy, just don't trust that person. Okay. He's just bluffing. So basically, let me explain you why. As I said, as we keep on adding more and more features to our model, what happens? The model complexity will keep on increasing as I add more and more features. But at the same time, even if your training accuracy goes up, okay, your test accuracy will fall. Why? Because out of this all 100 features, not all the features are contributing in determining my target variable. Why? Let us say out of this x100, only x60 are contributing to my target variable y. So the remaining 40 variables that you're adding are just noise. Someone asked me, right, what is noise? इसने तो पूछा ना मुझे, what is noise? So the presence of unwanted features, the presence of unwanted features, unwanted data, okay? If you're building a model with features which are not required, which are not contributing in determining your target variable y, these are an overhead. This is just noise, okay? So you are making the model unnecessarily complex, and that drags your accuracy, that brings down your accuracy, okay? So after a certain period, okay, let's say this is x60. So after x60, if you keep on adding more and more variables up to x100, okay, let us say the remaining 40 variables, if you keep on adding, it will just drag your accuracy down. Why? Because if you keep on adding variables which are not required, which are not important, which are not contributing in determining my target variable y, it will just drag the accuracy down. It will just bring it down. And that is the reason you can see that the curve is going down since here. Okay. So where should I stop adding complexity to my model? You should just stop where your test accuracy starts falling. If you keep on adding more and more variables, okay, and instead of the test accuracy increasing, if it starts to fall down, it starts decreasing. This is the point where you need to stop, and this is where you have found your just fit model or your generalized model, okay? So the point after which your train accuracy increases, but your test accuracy starts decreasing, that is where you should stop to make your model more complex. You should not make it more complex beyond that, okay? And that is how you achieve the just fit or your generalized model. Is this concept clear to you guys? Very much. Are you guys following? Not following? Okay, so they're clear. How about others? Is it making sense? Not making sense? Okay, Krishna, Sankirtana, good. Good. All right, so let's proceed now since you guys have understood all the concepts. Now let us go ahead. Yeah, so this is the right level of complexity. So let me clear the ink on the slide. Yes, so this is the right level of complexity, okay, where you can achieve your generalized model, okay. So you just have to keep an eye on the test accuracy or the validation accuracy. The moment after which the accuracy starts dropping, the test accuracy, you should stop making your model more complex. You should stop adding variables to your model, okay. All right, let us talk about the classification task, okay. So in case of a classification algorithm, what are the steps that we need to follow? Okay, given a collection of records, okay, which is also called as your training set. I'll tell you what is a training set, okay. So basically, if this is your entire data set, okay, let us say if this is your entire data set, okay, let us say we have x1 column, x2 column, x3 column, and so on, x4 column, and so on, okay, and you have a target variable, let's say, okay. So what we're going to do is we are going to divide this data set. Into train and test. Okay. So we are going to, let us say, randomly divide this like this. Okay. So this is 70% of the records will be your training data set, or it is also called as your training set. Okay. And the remaining 30% of the data set will be called as your test data set. Okay. Now, why we are keeping the test data set separate? Because we want to see how our model performs on this test data. We are not going to show this data to our model for our learning phase. We are just going to show it the 70% of the data, and we'll tell that, okay, now you have the x variables, you have the y variables, try to learn the relationship between the x and y, okay? And once the model is built, we are going to ask him, okay, if this is the data, new data, what should be the y for this? So predict the y. So we are going to ask you to predict the y for the test data. And since we already know the real values or y values of test, we can compare the y and y cap, basically the actual values and the predicted values of the test data, and see how our model has performed and what is the accuracy of our model. So the model which performs good on test accuracy, we are going to finalize that model. Okay. So the task here is find a model for the class attribute as a function of the values of the other attributes, which means what? This is the y variable, and we are interested to predict the y variable. So we are going to define y as a function of all the x variables, okay, as a function of all the input features. So y will be nothing but a function of all the input features. So basically y derives its value from all the input variables. It simply means that. Okay. Now what is the goal over here? The goal over here is the previously unseen records. Okay. So basically your test data should be assigned a class, okay, as accurately as possible. Which means what? Let us say these are your age and salary that we discussed already, right? So for a certain age and for a certain salary, if the value is y, for a certain age and for a certain salary, let's say the value is n. So basically not passed alone and passed alone. For another test set data, your model should be able to accurately predict whether it should be yes or no. Okay. And this particular accuracy is what we are trying to achieve over here. Okay. All right. Let's see how it is done. So this is how your typically data set looks like. As I said, this is your 70% of the data is split up into training set. The remaining 30% is split up into test set. Now you might ask, sir, ये हमेशा 70 or 30 होता है क्या? No. It can be 80 or 20. Okay. It can be 65 and 35. Okay. So basically क्या है? Majority chunk should be your training. Okay. And you should keep aside some minimal amount of data for testing purpose. Okay. Which means that in this case, all the input and the output values are known to the algorithm. Okay. And in case of test set, the output will not be known to the algorithm. Basically, we will ask it to predict it. We'll ask it to predict based on the training phase. So with this data, we make the model learn. Okay. So we have a learning algorithm. So it can be anything. Your learning algorithm can be your simple linear regression. It can be your multiple linear regression. It can be your logistic regression. It can be your decision trees, right? Based on whether it is a regression problem or whether it is a classification problem. You can use any of the algorithms based on the problem that you're trying to solve. Okay. We will follow the same mechanism for a regression problem as well as a classification problem. You need to first divide the data set into two parts, train and test, make the model learn based on the training data set. Okay. And once the model is ready, okay, once the model is ready, we will apply the model on the test data. So this is the test data and we'll ask it to do the predictions for us. And based on how it predicted, whether it predicted correctly or whether it did not predict correctly, right? Basically, it made a misclassification. We are going to determine how accurate is our model. Okay. So we'll see how to evaluate a model in the end of the session. But so far, are we clear, guys? How to apply any machine learning algorithm, be it your regression or a classification problem, by using this train and test split method? Are we clear so far? Yes. Okay, good. All right, let's proceed then. So yes, we talked about this already. We are going to split the data for model building phase. Okay. So in some cases, okay, in some cases, you can have the train and test only, or so let us say this is your data set. Okay. So in some cases, we can have 80-20, okay, or we can have 70-30 and so on. And this is your train and this is your test. Okay. But in some cases, what business does is, okay, in majority of the projects, how it happens is, in majority of the cases, what the business will do is they will take, okay, so let us say 60% of the data for, they'll give you for train, okay, 30% of the data will be for test, and 10% of the data they will keep for business validation. They will keep for business validation, which means that once you have trained the model, you have tested it on the test data, okay, then you pass that model to the business and they will validate on the validation set data. So you can either split the data in two parts, data set into two parts, or you can split it into three parts. Again, it depends on the clients, the different projects, the requirements, right? You can either go with two, majority we split it into two parts, which is train and test. And in some cases, we also go with train, test, and validation as well. With me, guys, so far? Is it clear why we split the data set, how we split the data set, in how many parts, right? Any questions on that? Is the discussion making sense? All right. So there is saying no questions. Okay. So I assume you guys are following. Okay, and let's proceed. So what are some of the classification tasks? So some of the classification problems can be like predicting whether the cancer cells, right? Basically, your tumor cells are nothing but your cancer cells, right? Whether they are belonging to a benign or malignant. So basically, is it a cancer or a no cancer cell? So we have cells in our body, right? So is that cell belonging to the, so basically this is like you will collect different attributes of the cell, okay, which is nothing but x1, x2, x3, and so on, all the features. So based on these features, your target variable is nothing but whether it is a cancerous cell or it is a no cancer cell. So basically, this is when you just have two classes. This is called as two classes. Okay. So when you have only two classes in your target variable, okay, either it's a cancer or a not cancer, right? This is also called as a binary classification. Why is it called binary classification? So as many of you might know, right? Binary means nothing but just two, right? Bi means two. So in case of computer students or IT students, you might understand that, right? Your computers or systems that are currently which we are using, right? They follow the binary mechanism, 0 or 1, right? Either a signal will be 0 or it will be 1, right? So basically binary is nothing but 0 or 1, or it can be yes or no, or it can be cancer, no cancer, right? So wherever there are just two classes involved, we call it as a binary classification. Okay. So when we apply, then this was from a bioinformatics field, we can talk about the banking industry as well. So in case of banking industry, you can classify the credit card transactions to be legitimate or fraudulent, or you can just call them as fraudulent and not fraudulent. Okay. So again, this is a classical case of binary classification. You can also classify your protein structures such as alpha helix, beta sheet, or random coil. So basically here you can see that we have multiple classes, right? So this is called as a multi-class classification. This is called as a multi-class classification when you have more than two classes. When you just have two classes, it is called as binary classification. But when we have more than two classes, that is called as a multi-class classification. Okay. So coming to the news industry, it can be your stories, news stories, or your web pages can be belonging to finance, weather, entertainment, sports, and so on. Is the classification task clear, guys? What do we mean by a classification problem? How do we classify? What is the definition of classification? We also saw at what kind of different models we can build: simple, complex, and generalized models, right? I hope all the concepts are clear before we actually jump into learning a classification algorithm. Clear? Please elaborate multi-class classification. Sure. So you can have the news stories as belonging to, okay, let us say you have certain features such as, okay, so same here, x1, x2, x3, x4, and so on. These are all your features, right? So let us say the target variable. The target variable you have, let us say based on these all features, I want to classify whether a story is a news story. Okay. Sorry, where is that news? News story, whether it is belonging to finance. So let us say this is finance. This is weather, this is entertainment, whether it is sports, right? So we have 1, 2, 3, and 4 classes over here. So when the number of classes are more than 2, we call it as a multi-class classification. Is that fine, Rohit? It all depends on how many classes are there in your target variable. If you just have two classes, whether a record or a transaction is, basically a cell is cancerous or whether a cell is non-cancerous. A data record, a data point, as we call it, one single row. A data point can only belong to either of the classes, be it your multi-class or binary classification. But one record, one row in your data set will correspond to only one class. The second row will correspond to the other class. You have this task of classifying which class that particular data record or data row should belong to, and that is the act of classification. So based on these input features, your machine learning model will assign a class to this, whether it is cancerous, non-cancerous, and so on, depending upon the input features that you build the model on. All right, guys. With me so far? Yes. All right. So what are the different kinds of classification techniques we have? We have the decision tree based methods. Okay. We have neural networks, nothing but deep learning techniques. We have naive based, we have support vector machines, we have k nearest neighbors. We also have logistic regression, which is a popular binary classification algorithm. Okay. Used for binary classification. Okay. So wherever you go, majority of the people will teach you logistic regression for helping you learn classification algorithms. Okay, but today we are going to look at decision trees. Okay, we are going to learn how decision trees work and achieve the act of classification. All right, so we are going to look at the decision tree based methods. Yeah, majority of them can be used for both. Even decision trees can be used for both classification as well as regression. All right, Rohit. So many of the techniques are not, specific to regression or specific to classification, such as your simple linear regression and your multiple linear regression are only regression. They can do only regression. Okay. Whereas logistic regression can only perform binary classification. Okay. It can also perform multi-class classification, but it is majorly used for classification purposes. Okay. Whereas few of the algorithms like, your neural nets, your decision trees, they can be used for both regression as well as classification. Okay, so few algorithms can be used for both, few can be used only for regression, few can be used only for classification, right? There is a plethora of techniques available out there, okay, that we can learn. But for the sake of discussion of today's session, we are going to only look at decision trees as a method for classification. All right. Okay, so where does this fit into the entire scheme of things, right? If you have to ask that question. So the model building or, whatever algorithms that we build, where do they fit into? So basically right from data gathering, right? So first we need to gather the data. Okay. We do some initial exploration on the data, that is also called as exploratory data analysis, right? Then we do something called as feature engineering. Okay. So we carefully select the features, basically your X1, X2, X3, and so on, right? And then we build these models based on these selected features. It can either be a regression you can be solving a regression problem. Okay. So where you can go for regression techniques, and whether you solve a classification problem, then you can go for classification techniques. Okay, so this is where we are currently looking at what kind of models we are building. We already looked at regression techniques, which are simple linear regression and multiple linear regression, and as a part of classification we are going to look at the decision tree algorithm today. Okay, then once you build a model on any of by using any of the techniques, right, you can use that model to generate predictions. Okay, and based on those predictions you can take business decisions. Okay, so we already talked about this in the first day session, right? And let us say if the model did not predict it correctly, we are going to send this particular prediction to the original workflow, right? As a feedback, we will be adding that same data point which was misclassified by our algorithm back to the original data set. We'll again follow this entire cycle of retraining the model with the new data which was misclassified, data point which was misclassified. And once your model rectifies, learns from the data, it becomes better and better. Okay, so once you deploy the model in production, your work is not done. You have to continuously monitor the performance of your model. If the accuracy is dropping, it is generating more errors, or doing more misclassifications, right? You need to retrain your model. You have to continuously retrain your model and again redeploy in production, so that you can maintain the accuracy of the model in production environment. All right, guys, with me so far? Shall we move to decision trees now? Yes. Okay. All right. So as a part of decision tree, right, we are going to see the implementation of C 5.0, okay, as well as CART. I'll tell you what these different implementations of decision tree are, okay, once we start with the discussion. All right. Now, what are decision trees, okay, or why the name we have given it the name as your, okay, remaining C programming. All right. So basically, why decision trees are called like that? What is the logic behind it, right? Let us try to understand that. Let us say our friend, so let us pick Rohit, okay. So let us say Rohit is looking for job opportunities and he gives interviews and successfully he gets 3 different offers. Okay, let us say he get multiple offers. So let us put over here. So Rohit, I'm just taking your name for example purpose. Okay, nothing personal about it. So let us say salary. Okay, so let us say Rohit has got multiple offers, right? So for Rohit, what is the most important thing in shortlisting the offers? Yes, Rohit. Salary, right? So the very topmost criteria for selecting the offer by Rohit is, what is the salary that you are going to offer? So let us say Rohit says that, okay, I'll only take those companies which are offering me minimum 50K salary. Okay. Minimum 50K salary. All right. And then he's going to look at the remaining set of things. Okay. So the final decision that Rohit needs to make, okay, the target variable here is why, whether which offer he will accept, whether he will accept or whether he will reject. Okay. So there are two classes. Okay. Accept the offer or reject the offer. Okay. So this is a binary class classification that we are trying to do. Let us say the first company which Rohit applies to. Okay. Let us say company A. Okay. They are offering him a salary of, let us say 52K. Okay. But the commute time, okay, the commute time to reach the office is, let's say he has to travel 1.5 hours. Okay. Then this freebies, is this company providing any freebies? No, this company is not providing any freebies. Okay. Let us say there is a B company. Okay. Now that company is offering him, let us say 49K salary. Okay. The commute time is just 20 minutes. Okay. There are also freebies that company is offering. Okay. Let us say there is a C company wherein the company is giving him a decent salary, 53K. Okay. The commute time is also less, let us say 40 minutes. Okay. And let us say, is the company offering any freebies? No, they are not offering any freebies. Okay. And there is a company D. Okay. Let us say the salary is 54K. Okay. The commute time is 45 minutes. Okay. And they are also offering him freebies. All right. Now, what I'm going to do is, first I'm going to take, okay, the company A. Now, what is the topmost criteria of Rohit? Rohit is saying that the topmost criteria is what is the salary that you're giving me. So I'm going to take salary as the topmost criteria. Okay. And I'm going to say, okay, whether salary is the condition of salary is getting satisfied or not. Okay. So the first company A, I'm going to take the company A, make it flow through this particular structure. Is the company A offering more than 50K salary? Is the company offering more than 60K salary rise? Is it offering more than 50K? Yes, it is offering, right? So this particular company A will go over here. That particular company A will come over here, right? Now, is the commute time more than 1 hour? Let us see, is the commute time, is it more than 1 hour, guys? Or is it less than 1 hour? More than 1 hour, right? So, what is the criteria? If the commute time is more than 1 hour, right? If the condition is satisfied, he will decline the offer. So what will happen with A, guys? Whether it will accept or decline the offer? Decline the offer. So the company A has been rejected by Rohit. Rohit is saying, "No, I am not going to take this offer. Even if you are offering me salary, the commit time is more, right?" So let us go with the B company. Now B company, right? What is the salary being offered by B company? It is 49K. What is the first criteria of Rohit? रोहित का पहला क्राइटेरिया क्या है? मिनिमम 50K सैलरी होनी चाहिए. I should have minimum 50K salary, right? Is this company satisfying the basic criteria? No, it is not satisfying, right? So Rohit is directly going to, he is not even going to think twice, right? He is just directly going to decline or accept the offer. Decline the offer, right? It is not satisfying his criteria. Now let us say the company C, okay? So the company B will go over here, okay? The company A has already gone over here, declined, okay? Now let us take the company C over here. Is it offering minimum 50K? Yes. It will fall through. Yes, it will come through this route. Is the commit time more than 1 hour? No, it is not more than an hour, right? It is 40 minutes. So this company will flow down over here. Is the company offering freebies, guys? Is the company offering free coffee? So Sudhir, is the company offering free coffee for him? No, it is not offering the free coffee, right? So if it is not offering free coffee, what Rohit is going to do? Decline the offer. So the C company will come over here, decline. So C company is also decline. Let us look at the D company now. First criteria, is salary greater than 50K? Yes, satisfied. So this company, when I make the D record pass from here, salary 50K, yes, come over here, this side. So now D company is falling through this tree structure. Is the commit time more than 1 hour? No, it is not more than 1 hour. It is less than 1 hour, right? So in the no criteria will come down. Is the company offering freebies, free coffee and everything? Yes, it is offering free coffee, right? Then only Rohit is going to accept the offer, which is your D company. So D company is going to accept the offer. Now, what did we do here, guys? What was the entire exercise that we did over here? We took every record or the offer which Rohit has got, right? So basically, we went row by row. We took row by row. We took first row, second row, third row, fourth row, right? Basically, each record, we made it to traverse through this tree structure. Okay, we made it to traverse through this tree structure, and then whichever falls through all the conditions. So what are these blue capsules over here? Whatever we have written, salary 50K, commute more than, freebies being offered or not. These are all your criteria, right? These are the conditions which Rohit has set for himself. So the topmost criteria is salary. So this is the topmost criteria. Second topmost criteria is what is the commute time. What is the third topmost criteria? What is the freebies being offered or not? So whichever companies passes through all these criteria, only that company Rohit is going to accept, right? So these are called as your, yes, exactly, Rohit. These are called as your nodes, decision making criteria, right? So these are also called as your decision nodes because they are helping you to make a decision, right? So the topmost decision node is also given a special name, which is called as a root node, right? So if you think this of an inverted tree structure, so this is the root from where the tree is growing, right? So if I just tilt this entire tree structure, right, it will look like this. So you start from the root, right? This is your root. So you start from the root, you start building the branches, right? So from the root only you start building the branches. Yes, no, the additional branch, right? So again it will go. And whatever is at the last, right? These are the leaf nodes. These green ones are called as your leaf nodes. Okay, so these are all called as your leaf nodes. The leaf nodes are the ones which carry your labels. Okay, whether you accepted the offer or you declined the offer, guys. Clear? Eh? So three things that you need to understand: leaf nodes, decision nodes, and your special first decision node is known as the root node because that is where the tree starts to grow from the root node. Okay, so you have intermediate decision nodes. So we have one decision node over here, one decision node over here, and then you keep on branching until you reach a final conclusion, whether you accept the offer or you decline the offer. समझ में आ रहा है guys? What is a tree structure? What we did exactly by taking example of Rohit over here. Yes, with me so far? Okay. So what is decision trees? Okay, so decision tree are built using a heuristic called as your recursive partitioning. Okay, this is also commonly called as your divide and conquer approach. Okay, because it splits the data into subsets. It splits the data into subsets, which are then split repeatedly into even smaller subsets and so on. And we keep on doing this until the data within the subsets are sufficiently homogeneous. Remember, guys, what is this concept of sufficient homogeneity? We talked about the act of classification. We want to do the classification such that we create pure regions. Okay, we create pure regions assigned to each class, or at least we create sufficiently homogeneous. Chalo pure nahi possible hai, so at least we create sufficiently homogeneous regions. Okay, or we have some other stopping criteria that has been met, which means what? We will take a criteria, we'll take a feature one. Okay, we'll build the tree. We'll take another feature, we build the tree. We'll take another feature, we build the tree. Okay, so we'll keep on doing this until we are able to clearly separate the data belonging to each class. Okay, or some certain criteria has been met. What is the certain criteria? We have something called as max depth. Max depth is nothing but a stopping criterion for building the trees, which means that after building the tree up to 3 levels, so this is a level 1, level 2, and level 3. So you should not split the tree further, but you should stop over here. Okay, so after reaching a certain level, maximum depth, okay, we stop building the tree further. So either a certain max depth condition has been met, stopping criterion, or you run out of features. Like this is the feature 1, here you have feature 2. Okay, remember, right? यहाँ पे देखो, salary was one feature, right? One feature. Commute time more than 1 hour. This is the second feature, yes or no? Commute time. So this is the feature 2. Then freebies. This is your feature 3, right? So do we have one more feature to build the extend the tree upon? No. You ran out of the features, right? You just had 3 features, and that is the reason you have just 3 nodes over here. Decision nodes. Yes or no? Are we guys getting this? You can only build the tree until you run out of features. Okay, so the maximum number of features you have, you can grow the tree only up to that particular levels. Okay, either you can keep on building the tree until you run out of the features. Okay, or you can stop building the tree until a certain stopping criteria has been met. All right, okay. All right. So this is the act of classification. Okay, we already talked about this. Okay, now let us see how we can build a tree. So here are the 3 features. Okay, so this is your feature 1. Okay, so this is the example of an income tax data set. So this is your feature 1, this is your feature 2, this is your feature 3, and this is your target variable y. Okay, the class variable is also called as a class variable. So how many classes we have? The number of distinct values. So we have no and yes. So basically we have 2 classes, yes and no. Okay, now based on these features, whether there is a refund expected from the income tax, whether the person applying for income tax return, whether he is single or married, okay, and what is his taxable income. So based on these features, we are going to build a tree such that we are going to predict whether he will cheat the income tax department, yes or no. Okay, so what I'll do, I'll take the feature refund. Okay, so I'll take the feature refund and make it as the root node. Okay, then I will say, okay, yes and no. Okay, how many distinct values we have in the refund column? We have yes and no. So I'm going to have 2 branches, yes and no. Okay, now what is the first record saying? The first record says that, okay, the refund is yes. So when I make this first data point pass through this roots tree structure, it will go whether refund is yes, yes, refund is yes. So what is the leaf node? No. So basically this person, if he is expecting a return, he will not cheat the income tax department. So I can directly put no to this and this will be done. The classification task will be done. Now I'll take the second record. No. So when I take, if refund is no, the data point will flow through this particular what you can say branch, right? Now, whether this particular person is married or not, right? So that is the second feature. So based on the second feature, I am going to build the next decision node. Whether the person is married or he is single or divorced, right? So whether he is married or whether he is single, divorced, right? Based on that, I'm going to make the data point flow through this branch or to this branch. Now this says that he is already married, right? So since he is married, there is less chance of that person taking risk and cheating the income tax department. So we'll directly go to the no leaf. So this is the leaf node. Okay. So this person will not cheat the income tax department and we have already labeled him as no. So let us take this example of yes. Okay. So the refund is no. The refund is no. This will fall through over here. Marital status is what? Divorced. Yes, divorced. We will go over here. Okay. And what is the last feature we have? Taxable income. Now, whether the taxable income is less than 80K or whether it is greater than 80K. Based on that, we will determine whether the person will cheat the income tax department or he will not cheat the income tax department. Now, if you see here, we have different values for taxable income. Okay. And if you look at this particular record that we are currently analyzing, so the amount is more than 80K, which is nothing but 95K, right? So this particular data point will fall through here, which is more than 80K, right? Which means that there is a good chance that this particular person might cheat the income tax department and we will label that particular person belonging to the yes class. Clear, guys, how we build the decision tree and how we make the data flow through the entire tree structure in order to reach a decision. Basically, we are predicting which class that data point will belong to. Are we following, guys? Yes. Are you guys with me? Okay. Now tell me, guys, should I always pick the first column as the root node? Like in this case, we have refund as the first column, right? Or the refund as the first feature. Should I always go with refund as the root node? Can't I take marital status as the root node? You might be getting this question in your mind, right? Which feature should I choose as my root node? How did Rohit decide whether he will think about the offer or not? What was his topmost criteria for selecting the offer? Priority feature, Rohit. Okay. So how do we decide which is the most important feature that should be chosen as a root node? Do we have that question in our mind now? First and foremost thing, we can choose any node, right? So here we had chosen refund. So this is what is the tree structure we got, right? Now, if I choose another feature as my root node, if I take marital status as my root node, am I getting a different tree structure, guys? Look at this tree structure and look at this tree structure. If I change my root node, the feature to be chosen as a root node, does the tree structure also change? What do you see over here? Does the tree structure change if I change my root node? Yes, it is changing, right? यहाँ पे मैंने क्या किया? I had taken refund as my root node, the first node, right? Decision node. And I got this kind of a tree structure. The moment I choose marital status, the entire tree structure has changed, right? So it is imperative that we understand how decision trees choose their most important feature, the most important root node, right? Barabar? Are we thinking that how can we choose this root node? Which feature to be chosen as root node? Do we have this question in our mind now? Is it based on lesser number of nodes? No, Kushi. That is not the criteria. Okay. Which feature should be chosen as root node? There is a certain logic behind it. Okay. So let's look at what is that logic. Okay. So all right. So this is how it happens when you apply it for the test data, right? So once the tree structure is finalized, अब tree structure finalize करना है तो I need to finalize what should be chosen as my root node, right? Once I finalize what should be chosen as a root node, I can finalize on the tree structure. And once the tree structure is finalized, I can take the test data. Okay. So if a particular data point is having test data as refund as no, it will go over here. If the marital status is married, it will go over here. And then I can directly assign the label, which is no to this particular data point. Assign cheat to no class. Okay. So that is how it happens. But it all depends on which feature I choose as my root node, because if I change my feature on the root node, the entire tree structure changes. And until you finalize on a tree structure, you can't use it for your test node, right? So let us see how decision trees, okay, determine which feature should be chosen as your root node and what should be my splitting criteria. ये जो है ना single divorce married या फिर ये less than 80K and greater than 80K, this is called as your splitting criteria. This is called as your splitting criteria. Okay. So there are two things I should know. First, which feature to be chosen as my root node, and second, what should be my splitting criteria? What should be the splitting criteria or splitting value? Like in this case, we want to understand how did this particular decision tree arrive that I should choose 80K as my splitting value. Okay. So the value to split on is also subjective. Okay. And which feature I should choose as my root node is also subjective. So if we are able to fix these two things, or figure out how we can assign these two things, it is very easy to build your tree structure. Okay. So for that, we need to understand how the decision tree chooses its root node. And once it chooses its root node, based on what splitting criteria, it will build the tree upon. Okay. So let us go and try to understand how decision trees do that. Okay. So for that, C 5.0 implementation of the decision tree uses the concept called as entropy. Now this entropy is a concept borrowed from the information theory that quantifies the randomness or the disorder within the set of class values. Now, how do we use this, or how does decision tree use entropy to find out? Okay, that will ultimately increase the homogeneity within the groups. Okay, so let us find out that. Let us take this example. Okay, let us say we have a data set like this, wherein we have the feature 1 as ball size, feature 2 as the ball color, feature 3 as my price, and the final target variable is nothing but whether based on these features, okay, that particular ball is useful for playing football or not. Okay. Now tell me, by looking at these features, how would you determine which should be your root node? Do you have a question whether I should go with ball size, ball color, or the price? Okay. Now tell me, at which value if I, okay, ball size, okay. Why not ball color, guys? Why can't I take feature 2 ball color as my root node? Yes, because it is the same value. All values are the same in the ball color, right? So unless you have variation, in your feature, it is not useful to take as the root node. Okay. So ball color cannot, this feature can never be your decision making criteria because it is the same. It is falling on one side itself. So you only have candidates, which is your ball size and price, that can be chosen as your root node. So we have two candidates to be considered for root node, which is your ball size and price. Now tell me which feature if I take, will result into homogeneous regions. मतलब क्या है? Let us say if I take the ball size, okay, if I take ball size as the root node, okay. Now on which value should I split these records? Like I have 10, 1, 50, 100 and 1000, right? So let us say if I say I choose less than, let us say, what is it? Less than 100, okay. So let us choose less than 100, less than or equal to 100 and greater than 100. Just I'm randomly choosing. Okay. So let us take the first data point. What will happen if I pass the first data point? 10. 10 is less than 100, less than or equal to 100. Yes. So 10 will go over here and I will have here your first data point. Okay. So the first data point, which is of wall size 10, what is the label for that? It is yes. Yes. I'll take the second data point. Okay. What is its value? 1. 1, is it less than, when I pass 1 from this tree structure, 1 less than or equal to 100 or greater than 100, guys? 1 is less than or equal to 100, right? So I'll take 1 over here. It will come over here. Okay. And is also having the label yes. Take the third value, which is 50. Okay. Third is also going to come over here and the label for that particular is also yes. Now take the fourth, which is 100. 100 less than or equal to 100, yes, but take the label. Okay. So the fourth data point will also come over here, which is having the label no. The only data point, fifth data point, which is 1000, will go on this side. Okay. Which is having the label, which is no. Now tell me, guys, is this a pure region? Are all the data points belonging to the same class? And here are all the data points belonging to the same class? Yes. It is only having one data point. So this is a pure region. But what about this, guys? Is it pure region? Yes, the one on the right hand side greater than 100 is a pure region. What about the left hand side? Is it a pure region? No, we have 3 yes classes and 1 no classes. So we say that there is still impurity. We say that there is still impurity at this particular node and we need to split it further. We need to split it further, okay, such that all your yes classes should go on one side and your no class should be on the other side. And that is when we will say that the decision tree was able to successfully divide the data set into pure regions. Let us say if we do not split it further, okay, we do not split it further. We only stop over here on this point itself. But tell me, is this at this particular node, are we having sufficient homogeneity? Which means that do we have a majority class? Do we have a maximum number of data points belonging to a specific class? Yes, we have almost 3 data points belonging to the yes class, right? Only one single data point is no. In this case, we say that this is sufficiently homogeneous. Sufficiently homogeneous or pure. Sufficiently pure or sufficiently homogeneous. Okay. Now this was just to take an example to help you understand. Okay. But tell me, if I choose a different splitting criterion, will I be able to get pure regions? थोड़ा देखो सोचो. For ball size, if I take a different value, I split it on different value, will I get pure regions? So Kushi is saying 50. Okay, let us say less than equal to 50, greater than 50. What happens? Let us see. So if you see here, visually also if you see here, right? यहाँ पे देखो. These all belonging to the no class. These all belong to the yes class. So if you split at 50, right, you will get pure regions. Okay. But yes, Rohit, we can do it on price as well. Okay. But price will not give you homogeneous regions like what ball size is giving you currently. Okay. So if you take price and try to do that, you will not get it. Because what will happen? You'll at least have one data point. Okay. You think of it, right? If you do less than equal to 5, right? All these will go in one class on one side. Okay. And only 10 will go on the other side. If you choose less than 1, only y will be there and these all will go on the other side. Okay. So you'll never achieve a pure what you can say regions based on that. So what decision trees will do is they will look at for such criteria such that it will result in pure regions, right? Okay. So if you choose less than equal to 50, your first, second, and third data point will all belong to yes class, will go over here. The fourth data point belonging to no class and fifth data point belonging to no class will all go on the other side. So this way, this ball size feature based on this splitting criteria is going to give me homogeneous regions, pure regions. Okay. And that is the reason why this will choose root node as ball size, because price will not give me this particular thing. Now, this is what we are able to do when we are visually looking at this particular example. But machines will not do it visually, right? They don't have logic. They don't think it the way in which we thought, and we looked at, okay, at which criteria we get pure regions. They have to go with certain formula. Now, what is that criteria or formula which is being used? So they use this concept of entropy, okay? So we need to quantify in numbers the usefulness of the columns or features. And based on that only, we are going to determine which feature to be chosen as our root node. Okay, so let us look at this. So this is the information gain. Okay, now information gain, we have to calculate the information gain for that particular feature, for each feature basically in our data set. Okay, so for all the features in our data set, we are going to calculate the info gain, and the feature which is going to give me the maximum information gain will be chosen as my root node. Okay, so for that we need to understand, okay, how to calculate the entropy. So entropy, okay, entropy we have to take before the split, and we have to subtract the entropy after split. Okay, we have to, so if we take this particular thing, right, ball size. Okay, so before split we need to calculate the entropy here, entropy before split. Okay, and you need to also calculate this entropy after split. Okay, this is E1, and you also have to calculate E2, which is nothing but entropy after split. Okay, so you need to combine both these. Okay, this will together give you S2, and this will give you S1. You need to subtract the entropies after split, so S1 minus S2, and this will give you your IG, information gain. Okay, so in order to calculate the information gain, we will be using this particular formula, okay, for entropy. This is nothing but summation of all the proportionate of the classes, okay, at that particular point, okay, multiplied by your WI. Okay, so this is the formula basically. Okay, we apply and we calculate this in this similar fashion. Okay, and the one which gives me the highest information gain will be chosen as my root node. Okay, so that is the logic behind how your machine learning algorithm chooses which particular feature to be chosen as your root node. All right. Okay, I would have done the calculation and shown to you. Okay, Khushi, but the problem is we are very much short on time. It's almost 8:45. Okay, so I'll just run you through this. Okay, so I'll not take this example because we already have understood with Rohit's offer. Okay, that example. So I'll skip this for now. We'll talk about how to prune the decision tree. Now, what do you mean by pruning the decision tree? We talked about three different kinds of models. Remember, guys, we talked about simple model, we talked about complex model, okay, and we talked about a generalized model. Now, when you build the tree, you can build the tree like this, okay. You can build the tree like this. You can build the tree like this, okay. Now, you keep on building the tree until you have reached a certain splitting criterion, sorry, stopping criterion. You reached a certain stopping criterion, like your number of levels, right? How many levels should the tree grow up to? How deep the tree should grow? So you have something called as your max depth as your hyperparameter, using which you can control the depth of your tree. Okay. Or else what will happen? If you have 100 features, the tree will keep on continuously growing until it is able to sufficiently classify them into homogeneous, right? So it will keep on growing. Okay, it will keep on growing. The more and more levels the tree keeps on growing, it becomes more and more complex. Remember, our goal is to not build a complex model, and in order to stop the decision tree from getting more complex, right, we need to prune the tree. Now, what is this pruning? Pruning is nothing but, as in general our trees grow, right? If you go through the highway, right, there are trees which are built in, in between. So मान लो ये आपका highway है, right? So this is the ongoing traffic, this is the coming traffic, right? So there are trees planted in between the divider of the road, right? And if the trees start growing, in any haphazard manner, right, they will start blocking the traffic as well. So what you need to do? You have to continuously keep on maintaining, cutting down these trees, right, so that they remain in shape. Okay, you cut down these branches so that they do not come out of this divider space, right? So you need to keep on cutting those trees. That is called as pruning the tree. So similarly here, in order to avoid the tree from growing too complex, we need to prune the tree, which means that we need to cut the tree. You can cut the tree over here, you can cut the tree over here, okay? So this process of cutting the tree, okay, in order to not grow, make it not grow complex, okay, that is called as something like pruning the tree. And for pruning the tree, okay, we use this max depth feature to stop the tree from growing further and further. And in this way, since you are not building complex tree, we are avoiding the problem of something called as overfitting. Overfitting, right? Overfitted model is nothing but the complex model. It is the complex model, okay? And our goal is to reduce the size of the tree such that it generalizes to the unseen data. So basically, it should perform better on unseen data. That is what is our goal is over here, okay? So that is what is meant by pruning the tree, okay? Now the same concept can also be implemented using CART. CART is nothing but classification and regression trees, okay? That is also another mechanism of building trees. In this case, we don't work with information gain, okay? Instead, we work with something called as Gini impurity. So here we are trying to find out the feature to be chosen as root node in case of entropy, okay? Entropy, okay, or you can also call it as C5.0, right? The one which we saw earlier. So in entropy, what is our goal? Our goal is to choose a root node such that it results in homogeneous region. Opposed to that, in CART, what logic is applied is Gini impurity. Now, what is Gini impurity? Gini impurity is nothing but, okay, so in Gini impurity, let us say at a particular node, okay, let us say this is a particular node, okay, and I have 2 no classes, and let us say I have 4 yes classes, okay. The goal of Gini impurity is to split this particular node into such that it should result in least impurity. Least impurity का मतलब क्या है? More and more purity, just the opposite of purity, right? Least impurity. So this should result in NN, and this should result in all yes, yes, yes. So this is what is the wordings are opposite, but the goal is same, okay? To achieve maximum purity and minimum impurity, okay? So that is what is nothing but the concept of Gini impurity, which is used in your CART or classification and regression trees, okay? So either you build the tree using decision trees C5.0 or you build it using CART, doesn't matter, okay? The tree structure will always remain the same. Only the method to calculate the purity, okay? Purity and the impurity. जब आप impurity calculate कर रहे हो, तो it should be least, and जब purity calculate कर रहे हो, in case of information gain, the purity should be highest, okay? So that is the only concept change in between both these different methods, okay? All right. Khushi, we are not going to prune the feature, okay? We basically prune based on the levels, like how much you should grow the tree. So let us say the max depth is up to 3 levels. So up to 3 levels is nothing but 1, 2, and 3. You can't go beyond this. Stop. You can't grow the tree beyond that, okay? So based on the levels, okay? So Rohit, you don't need to get confused, okay? There we calculate purity, here we calculate impurity for homogeneous regions, nothing else, okay? All right. Okay, now once we have built the decision trees, how do we measure the accuracy of our decision tree or any classification technique for that matter, okay? So for that, we have a measure called as accuracy, okay? Like we had R square in case of our simple linear regression and multiple linear regression yesterday that we saw, right? To assess how good is our model, right? So similarly for classification techniques, how do we validate our model? We can calculate the accuracy, okay? Now we can calculate the accuracy, we can go for accuracy only when, let us say we have these features, okay? Some features, okay, X1, X2, X3, and so on. And this is the target variable. Let us say cancer and cancer, no cancer, no cancer, okay, no cancer. If I have equal number of observations, like here I have 3 observations belonging to the cancer class, I have 3 observations belonging to the no cancer class. if my data set is having equal observations with respect to the classes, okay. So in this case, let us say 3 and 3, then I will say this kind of a data set is called as a balanced data set. This kind of a data set is called as the balanced data set, okay. But in this case, let us say if I had two more no cancer, no cancer. So in this case, this would have been 5 no cancer and 3 cancer. In this case, there is no balance between the observations belonging to each class. And in this case, we call the data set as imbalanced data set. Imbalanced data set. Okay. Now, depending upon whether you are working on a balanced data set or an imbalanced data set, you need to determine which particular accuracy measure you should go for, or the validation measure you should go for. So if your data set is balanced, okay, you can go with accuracy. What is accuracy? Accuracy is nothing but the number of correct predictions made to the total number of predictions. So for that, we have to take an example to understand, okay. But how are we doing on time? Okay, 5 minutes we have. Let us quickly conclude this. So let us say this is your original variable, okay, or original value of y. This is the y cap which is predicted, okay. Let us say my model predicted 1, okay. My model value is actual value is 1. My model predicted as 1. So this is the correct prediction. Let us say let us say I have two classes, 0 and 1, okay. And my model predicted here 1. So in this case, expected value was 0, but my model predicted 1. So this is not a correct classification, okay. So similarly, let us say I had 0 and I had 0. This is the correct prediction, okay. So I had a 0, or let us say, okay, 1 1 0, okay. So this is, let us say this is 1, actual was 1, my prediction was 0, okay. So in this case, this is not the correct prediction, okay. Now I have these 4 observations. So we build something called as confusion matrix. Now what is this confusion matrix all about? Okay, the confusion matrix is built like this, okay. So this is 1, this is 0, this is 1, this is 0, okay. So this is your actual data, this is your predicted data, okay. So basically this is your y, this is your y cap, okay. Now if you take the first observation, my actual was 1, predicted also was 1, okay. So basically I'll say that the actual was 1, the predicted was also 1. So basically one observation I will add in this particular column. Now I'll go with the second one. Actual was 0, but predicted was 1. So actual was 0, but predicted was 1. So basically I will have one more over here. Actual was 0, predicted was also 0. So actual 0. So actual 0 ka hai yahan pe 0, actual 0 or predicted 0. So this is one observation over here. And actual was 1 and predicted was 0. Actual was 1 and predicted was 0. So I'll add one observation over here. So if you look over here, one observation is here, one observation is here, one observation is here, and one observation is here. So when the actual was 1 and predicted is also 1, so this is the correct prediction the model made. And when the actual was 0 and the predicted is also 0, my model made the correct prediction. So if you see here diagonally, these are the correct predictions which my model actually made, these ones. Okay. And if you say this as A, B, C, and D, okay. So the accuracy is nothing but A plus D. Basically the correct predictions made divided by the total. So in this case, here I have one observation here, one observation over here. So this will be 1 plus 1 divided by 4, which is 2 by 4, which is nothing but 1 by 2, which is nothing but 50%. So the accuracy of the model here is 50%. Okay. Are we getting this, guys? Everyone? How do we construct the confusion matrix? And how do we figure out the accuracy of that particular? Yeah, you can have more observations, Kushi. You just need to keep on classifying. Okay, whether I should add it over here. So let us say if we had more values over here, 1 0 0 1 1 0 0 0 and so on, right? Just keep on adding where they belong to. Okay, just keep on adding where they belong to. Okay, plus 1 plus 1 plus 1 like that, and then take a final count, apply this formula, and then find the accuracy. That's it. Okay. Oh, type 1, type 2. Okay. So tell me over here, Rohit, which one is more serious grave error? Which is more serious error? Saying that a male is pregnant or saying that a pregnant woman is not pregnant? Which is more serious error? False. False negative. But can a male be pregnant, Kushi? Can you say a male person is pregnant? Okay. All right. In general, this is more serious error. Okay. In general, this is more serious error. Okay. This is still evident, right? This is still evident. You can still make out. But here you cannot conclude a male to be a pregnant, right? So type 1 errors are more serious or grave errors. You cannot live with type 1 errors. Okay. All right. We'll talk about it on some other day, but let me quickly cover up what in case of imbalanced data set. So that is accuracy measure is applicable when you are working with a balanced data set. But when you're working with an imbalanced data set, wherein we have unequal number of observations for each of the classes, okay, in that case, we have to go with something called as recall and precision. Okay, so recall and precisions are nothing but how much of the actual values that you have predicted. So let us talk about recall. Recall is nothing but TP divided by TP plus FN. So TP divided by TP plus FN. So I'm talking about this particular thing. Okay. So out of the actual positives, how many was my model able to accurately predict as being positive? Okay. Or out of the actual ones, how many my model correctly predict as ones? Okay. So that is a measure of the same. So TP divided by TP plus FN. Okay. Now, what is this precision? Precision is nothing but TP divided by TP plus FP. So if you come over here, TP divided by TP plus FE, which means that out of the predicted ones, out of the predicted values, how many were actually positive and how many we did not correctly identify as positive. They were false positives basically, right? So this is nothing but TP divided by TP plus FP is all will give you your precision. So what is the ideal model? The ideal model should have high recall and high precision. Okay. So this is the recall and precision. So in case of imbalanced data set, you should go with recall and precision. Okay. Because those are class specific accuracies. All right. And if I want to take a harmonic mean of recall and precision, I can go with the F1 score, which is nothing but the 2 PRA divided by P plus R, nothing but the harmonic mean. This is the harmonic mean between precision and recall. Okay. So we can go with this measure as well for finding out how good our model is in case of imbalanced data sets. Okay. So that's all, guys. With regards to classification techniques, we discussed about what is classification, what are different classification techniques. Okay, out of which we discussed about decision trees and CART, which is classification and regression trees. What is the logic behind which using which they build the trees? Okay, and once a tree is built, how we can use it for prediction purposes? Okay, now once a model is built, be it classification or regression, right? What are the validation techniques, right? So in this case, we for a classification model based on whether it is a balanced data set or imbalanced data set, we will go for either accuracy by building the confusion matrix, or in case of imbalanced data sets, we can go with precision recall or the F1 score. These are the measures to validate how good your classification model is. All right. And that covers the agenda for today, guys. So that is what we wanted to cover for today as a part of our day 4, which is nothing but for supervised machine learning classification techniques. All right. I hope this session gave you a gist of what classification techniques are. Okay. Though we could have gone in more detail, but due to time constraints, I could not explain you in more detail. Okay. But we usually cover this as a part of the course that we have at ExcelR. Okay. So 80 hours of course we have wherein we discuss this concept for almost 4 hours. Okay. But yes, I was given only 2 hours to cover that entire topic. So I have covered it at a high level. Okay. But definitely you guys can learn more by doing your own due diligence. Okay. If you are interested to dig deeper in how these techniques work actually. All right. I hope the session was useful. Kushi, I would have loved to explain, but time is the only constraint. Same for you, Rohit, as well. But at least I think you might have got a high level overview of what these techniques are, what kind of business problems we can solve using these techniques, right? Has it given you at least that idea? What kind of examples that we looked at, right? So how a model is trained, what are complex model, what are simple models, what is a generalized model, and why do we aim to build a generalized model? I think all that logic is very much clear to you guys. Okay, Rohit, yes. Arya is saying yes. Great. Sudhir. All right, Kushi. Great, Rituja. Good to know that the session was useful to you guys, at least in some perspective. Okay. We will cover the last day of this 5-day series tomorrow with natural language processing. Okay. So we will visit NLP and the techniques within NLP. Okay. Tomorrow in tomorrow's session. So see you guys tomorrow at same time. Okay. Till then, take care. Have a great night. Over to you, Amar, in case you want to have some concluding comments.
Yeah, sure. Thank you so much. Nothing, guys. Please mark your attendance. I'm sharing that once again in the chat box. Please mark. And if you have any query or question for me, please drop in the chat box. There is one question. Sir, will you provide any course after completion of this course? Yes. From next Monday, we are going to start data analyst for 10 hours. So in the tomorrow session, I will share that link. Omkar saying site is down, showing 404 error. Let me check. Yeah, maybe. Sir, can you arrange course for image processing? I'm not sure, but in future, definitely. Omkar, recorded sessions are there. Please check carefully. All 4 days are recorded sessions are there. So there is one question, how to get recorded sessions. So you will get the recorded sessions over LMS. I hope you have LMS access. And still, if you're facing any difficulty while accessing the LMS, please drop an email to edl@excelr.com. Our team will connect with you. I'm sharing that email ID in the chat box. Please write it down. I think there's no more questions. So thank you so much, all of you, for joining the session. We'll meet you on tomorrow at same time. Can we listen the recording session after completion of our course? Yes. So I would like to inform you that recording sessions will be there for lifetime with you.